let's skip example 8. You can look that up in the PDF file later if you want to. But let's go ahead and look at example 9 because I know the vertical ones are the ones that we struggle with the most. So we want to find the volume of the solid formed by revolving the region bounded by the graphs of y equals x squared plus 1, y equals 0, x equals 0, and x equals 1 about the x-axis. So let's start by graphing that. All right, x squared plus 1 is going to be a parabola that's just shifted up 1 unit. So that's going to look like this. Sort of. My dots aren't great. Y equals 0 is the x-axis. X equals 0 is the y-axis, and x equals 1 is this one. So you can see the region that we end up with is this should be a little bit more like that. This region here is what we are interested in. My parabola got a little haywire over here. Okay, so let's try to get all of this extra stuff off of here now that we have identified our region. Oops, I don't mean to take rid of that. Okay, so there we go. We want to rotate that about the y-axis. And so that means that our axis of revolution is this right here. Our first question is always, is this a disk method or is this a washer method? Disk method means there is no gap between our region and the axis of revolution. Washer method means that there is a gap. And unfortunately for this problem, the answer to both is yes. Do you notice that if I cut this figure in half, kind of right here where this green line is, from the bottom down, there is no gap. Our radius is just 1. But above that, so from 0 to 1, there is no gap. But from 1 to 2, there is a gap. So we're going to have to set up 2 integrals for this example, okay? The first integral is going to be the bottom piece, and that is going to have no inner radius because that's going to be a solid disk. So that's just the disk method. So this bottom half here is going to use disks. This top half here is going to use washers because this is going to give me like a bowl, that top, when I rotate it around. And again, we're rotating around the y-axis this time. Okay, so let's think about our rectangles. In this bottom piece, our rectangles are going to stay the same the whole way up. The radius is always going to be 1. Now you could set this up using an integral, or you could just set this up using the volume formula for a cylinder because it's constant. It's not going to make any difference. But if we do it as an integral, the bottom half is going to be pi times the integral from 0 to 1. Now that is 0 to 1 in the y direction, not the x direction, because we're integrating dy since it's a vertical axis, of the radius, which is 1 squared dy. There's no variables there because it just has a width of 1 the whole way up. Plus, now we need to do the top, and that is going to have an inner radius and an outer radius. The inner radius is going to be this distance right here, the void space, and the outer radius is going to go all the way out to the edge. That is our capital R, all right? Now, the equation that they gave us is solved for y. Since we're going vertical, we need to solve this for x. So let's bring that over here. If I know that y is equal to x squared plus 1, then I know that y minus 1 is equal to x squared, which means plus or minus the square root of y minus 1 is equal to x. Since we are working on the right side, we only need the plus, okay? So capital R goes all the way from the y-axis out to the line x equals 1. So that is going to be capital R for this one. It's just a distance of 1 because, again, this vertical line here is never going to change. Its distance is always going to be 1. However, little r measures from the y-axis to the curve. And that is what that function does. X equals the square root of y minus 1 measures from the y-axis to the curve. And so little r is going to be the square root of y minus 1. And so our integral is going to be pi times the integral from, this time we're going from 1 to 2. That's the bowl part of our figure. And we are going to do capital R, which is 1 squared, minus little r, which is the square root of y minus 1 squared dy. And so that is going to be our integral. Let me move this. That's a little bit better. You can see a little bit better now. dy. That is the integral that we will use to find the volume of this solid. So this one has got a mix. Again, there's no subtraction here because these are just solid discs. Here there is subtraction because the top half, the bowl part, makes a washer. So you might have to set up 2 integrals, and that's going to be okay. All right? So I know that was kind of a long one, but that is the end for this unit. And guys, that's the last one for the entire class. We have now covered all of Calc AB. So proud of you. Let's start working for that AP test.